Hello everyone, Totally Legit Lectures here. Today we're going to be covering a topic from radioactivity called half-life. Now before we dive in, we first have to ask ourselves as to what is half-life. Well, in short, half-life is just the average time for any radioactive substance to become half its initial activity. Now I'm going to give a more visual example of half-life so that our previous definition makes a bit more sense. Okay, so here's a highly zoomed in image of a substance. As you can see, there are a bunch of atoms here, and depending on the type of radiation, these atoms will randomly decay and emit either alpha and beta particles or gamma rays. However, that doesn't matter here. What matters is that as these atoms continue to undergo radioactive decay, there will be a time where exactly half of these atoms will have decayed away. When that happens, we can say that this substance has finished its first half-life. Okay, now I'm going to give a breakdown of the entire process of half-life. Now, the whole process of half-life is random and spontaneous. To make this sentence easier to grasp and visualize, imagine that you're cooking some popcorn in a microwave. Pretend that the popcorns are the atoms. Now, when you're baking your popcorn, you can never tell which corn will pop and at what time. This is what being random means in the context of half-life, since we can never predict when an atom will decay. Also, you can never adjust the speed at which these corns will pop. They all pop automatically and are not affected by any external properties such as heat or pressure. This is what being spontaneous means in the context of half-life, since the whole process of an atom's decay is unchangeable. Despite all this chaos, we can still find a sequence in the whole system. Even if you can't tell when an atom decays, you can at least figure out when half of these atoms will decay. In short, predictability of when half of the atoms in a substance decays is called half-life.
Now that we have concluded what half-life is, now let's go to the questions. Question 1. Radioactive substance has a half-life of 30 minutes. What fraction of the atoms will not have decayed after 1 hour? So we know that the half-life of this substance is 30 minutes. So in 1 hour there will be 2 half-lives. I'm writing HL, short for half-life. So basically, that's 1 divided by 2, that's going to be half. And then we have to half that again. So divide by 2, that'll be 1/4. And that's going to be the answer. So let's write down answer. Now let's move on to the second question. Here. A researcher measures 200 counts per minute coming from a radioactive source at midday. At 3 o'clock, she finds that this has dropped to 25 counts per minute. What is the half-life of the radioactive source? Now, firstly, let's see. So first, it has dropped to 25 from 200. So that is equivalent to 1/8. So basically, started at 12 and then ended at 3. So basically, we'll do the rough work here. So 200 divided by half of that is 100, and then half of that is 50, and then half of that is 25. So we have reached 25. That's 1, 2, and 3 half-lives. So it took 3 hours. So for 3 half-lives, it took 3 hours, and for 1 half-life, it would take 3 divided by 3 hour. That's 1 hour. So each half-life is about 1 hour. Thank you for watching, guys. Stay tuned.